Section 4.3, logarithms. So we know that 2 squared equals 4 and 2 to the third equals 8. Why am I underlining that? I have no idea. Sorry. Okay, if I asked you 2 to what power will give you 16? Well, that's pretty easy. All you got to do is set up this in your mind. 2 to what power gives you 16? And you know that the answer is 4, right? But what if I asked you 2 to what power gives you 6? Then mental math no longer cuts it. We need logs and calculators. So in this case, 2 to the x equals 6. We would set up the logarithmic situation, x equals log base 2 of 6. I know that doesn't make sense right now, but it will in a little while. Now here's the key concept. This is what we need to learn. And if you read it for the first time, it's not going to make sense. But here's the truth that we're going to need to understand in the next 5 minutes. Log base b of y equals x if and only if b to the x power equals y. Sounds confusing, but you will understand it in 5 minutes. Let's first start off by understanding how to read this. So let's all go to our paper right here and write this down. Write it out in words, log base 2 of 6. We need to know that this is how you read it. This little number down here is the base of a logarithm. And whenever you read this, you say log base, you have to say the word base. Base 2 of 6. Whatever number this is, you're going to have to throw the word of right before it. So you read it log base 2 of 6. That's how you read it. Let's go back over here. And before we actually jump to how logs work, let's throw some vocab words out there for a little while. A common log is a logarithm with the base 10. Okay? A common log is a logarithm with base 10. Now listen to this. If there is no base, then assume it's base 10. So if I have something that says log of 1,000, notice that I didn't say log base something. In other words, there is no base down here written there. So if there is no base down there, I assume that it's base 10. Okay? Keep that in mind. Kind of like when you have a variable, x, and I ask you what number's in front of the x. You don't say, oh, there's no number. There's actually an invisible 1. Same thing with common logs. Logs that don't have a base shown right here, you automatically assume it's base 10. What else do we need to cover? A natural log. What is a natural log? It's a logarithm with base e. Okay? Now, you're probably thinking, what the heck is the number e? And what we need to do is understand that e is an irrational number. So you might want to jot this down somewhere. E is actually 2.718281828, and it continues forever, and it doesn't have a pattern, but we're just going to say it's similar to 2.718, or you could just say 2.72. All right? So E is an irrational number. It's kind of like pi. It's kind of like pi 3.14 that continues forever. But E is just 2.718. It continues forever. It's irrational, but it's just a number. Okay? So whenever you see the variable E, you're supposed to think 2.72. If I say I have E dollars, what are you supposed to think? That I have $2.72. All right? E is just a number. Don't freak out. But anyway, if we go back to natural logs right here, what is a natural log? It's a logarithm with base e, which is that irrational number 2.72, right? And instead of being written as log base e, it's usually written as ln, okay? So if we have ln of, let's say, 10, well, that's really saying log base e of 10. Okay? Just keep that in mind. ln is really log base e. And what is e? It's 2.72, roughly. Kind of like pi is 3.14, but it's not really 3.14. It continues forever. Same thing with e. It's an irrational number. We're just going to call it 2.72. Anyway, let's finally get to the stuff that makes sense here. Let's start understanding logarithms. And what we're going to do is, let's pretend you didn't see this answer, okay? Let's pretend that you're focusing in just on log base 2 of 8. So how do we know that the answer is 3? What we need to do is think this base of the logarithm, you need to think of it as the base of an exponent. So you're really going to be thinking 2 to what power gives me 8? 2 to what power gives me 8? And what's the answer? 3. 2 to the third power gives me 8. Okay, so over here, 4 to what power gives me 16? And that's how I get this answer. 4 to what power gives me 16? 2. That's why my answer is 2. 4 to the second power gives me 16. Is this starting to make sense? Guys, this is where it needs to click. This is where you need to be like, oh, wait, I get it. Right? If you're not getting that moment, you're going to miss a train here. This is it. 5 to what power gives me 1 as an answer? 5 to what power gives me 1 as an answer? 0. That's why the answer is 0, because 5 to the 0 gives me 1. So this is a common log. That means that there's an invisible base 10 right here. So when you think about it, 10 to what power gives me 10? The answer is 1. 10 to the 1 power gives me 10. B to what power gives me y? That's exactly it. B to what power gives me y? B to the x gives me y. Is this starting to make sense? Okay, it's all, you got to take your logarithmic form and use that base to write it as a base of an exponent, and you're going to be thinking that base to what power gives me this answer. So pretend, like, look, let's actually move down over here. Let's not look at, let's not look at that right there, okay? Even though you can still see it. But if I ask you, evaluate log base 8 of 64, what am I really asking you to do? I'm asking you to think of this way. 8 to what power gives me 64? What's the answer going to be, guys? 2. That's it. So when they give you the question, log base 8 of 64, what's the answer? You're just going to put a 2 right there and you're done. Is this making sense now? I hope so. Ladies and gentlemen, so on the back side of your worksheet, we want to practice, and we want to practice. They're already giving us the answers. Please pay attention. The answer is 2 right here. Now, if you didn't see the 2, what would we do? We'd think 8 to what power gives me 64? Oh, the answer is 2. What they want us to do is to rewrite this logarithmic form into exponential form. So let's actually do that right here next to number 1. 8 to what power? To the second power gives me 64. Got it? How about you guys try numbers 2 through 8 right now? I'm just going to pause it and post the answers so you guys can check them in a couple of seconds. So hit pause if you're at home right now and work them out. So there are the answers for 2 through 7, but let's work on number 8 together. 7 to what power gives me 7? 1, right? So when I rewrite it in exponential form, it's 7 to the 1 power gives me 7. Now this brings up a very, 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 very important truth before we go on to number 9. Anytime you have log base something of that same something, it's going to cancel out and equal 1. You with me? Log base 3 of 3, what is it? Log base 7 of 7 is 1. Log base 2 of 2 is 1. Log base salgado of salgado is 1. Okay? So that's the bottom line. When you have log base something of that same something, you could even do this if you wanted to. Just scratch it out and, because it equals 1. Okay, that's always going to be the case, and it's going to become very handy. Okay, switching my voice here. The class is out. I'm by myself, so I don't have to yell anymore. Yeah, so log base something of that same something cancels out because it equals 1, and that's always the case. So right here, log base 7 of 7 cancels out because it equals 1. Log base 3 of 3 cancels out. It equals 1. So up here cancels out because it equals 1. So log base something of that same something is always going to equal 1. And we're going to be using that a lot in the future. This last one, number 9, you want to rewrite it in exponential form. You're going to say b to the x power gives you y. Okay? So let's move on down to this part over here. We'll actually begin this next portion on the next video.